Hello friends, today we are going to discuss inverse Laplace transform. In previous two lectures, we have completed Laplace transform. So in inverse Laplace transform also you need to remember few formulas of inverse Laplace transform, but it is nothing new. It is just the inverse of Laplace transform formula. So first formula of Laplace transform, it was Laplace transform of 1 is 1 by s. So here you can write inverse Laplace of 1 by s is 1. Right? Second formula. What was the second formula of Laplace? L of e raised to at is equal to 1 upon s minus a. So for inverse Laplace you can write 1 upon s minus a is equal to e raised to at. Third formula, L inverse. In Laplace transform, the formula was L of sine at, right, is equal to a upon s square plus a square. So here you can write L inverse 1 upon s square plus a square is equal to 1 by a sine at. So actually it is L inverse a upon a square plus a square, but a is constant, so you can write on right hand side. Fourth, L inverse s by s square plus a square cos at. Fifth formula, two hyperbolic formula, L inverse 1 by s square minus a square is equal to 1 by a sine h at. So in order to understand the concept of inverse Laplace transform, you have to understand first Laplace transform and then you can go for inverse Laplace transform. Cos h at. And 7, L inverse of 1 by s raised to n plus 1. There are two cases, okay, t raised to n by gamma n plus 1 and t raised to n by n factor for rational number, and if n is integer then you can use this formula. Clear? Now we'll take particular example of each formula so it is easy to understand. First, if I'm asking for L inverse 2 by s, so inverse Laplace is also linear transformation, so 2 is constant and you can think about L inverse 1 by s, so you can say it is 2, right? Second, if it is L inverse 1 upon s minus 4, you can write e raised to 4t. For third, L inverse 1 by s square plus 9. And what is the inverse Laplace of 1 upon s square plus 9? You can write 1 by 3 because a square is 9, so a is 3. 1 by 3 sine 3t. So this practice is very important to solve previous questions. S by s square plus 16. So you can write cos 40, right? Fifth, 1 upon s square minus 1. What is a? A square is 1, so a is 1, so 1 by 1 sine h t. L inverse s by s square minus 25. It is cos h 5t. Okay, now I will take one more two questions for formula number 7. L inverse of 1 by s raised to 3. So where n is integer, so you can apply this formula. But n plus 1, not n is 3, but n plus 1 you can compare with this formula, left hand side part. So n plus 1 is 3, so n is 2. That is why t square by 2 factorial, right? You can write t square by 2. Same question, same formula. L inverse 1 by s raised to 3 by 2. Think about it. Okay, here 3 by 2 is rational number, so 3 by 2, n is 1 by 2, because n plus 1 is 3 by 2, so you can say n is 1 by 2. So t raised to 1 by 2 by gamma 3 by 2. And what is gamma 3 by 2? You can simplify as per the property of gamma function. Gamma n is equal to, gamma n plus 1 is equal to n gamma n. So 1 by 2 gamma 1 by 2, 1 by 2 gamma 1 by 2, but gamma 1 by 2 is root pi. Clear? Now we will go for some advanced example of linear transform, Laplace transform, sorry. Okay, now think about this question. L inverse of s square minus 1 square divided by s raised to 5. We don't have a direct formula to find out the inverse Laplace of this function, right? First we will simplify it. So what is the square of s square minus 1? S raised to 4 minus 2s square plus 1 divided by s raised to 5. Okay, then you can write L inverse 1 by s minus 2 by s cube plus 1 by s raised to 5. Now we have three different terms. You can apply previous formula. So which formula is suitable? Formula number 7. So as per this question, we can find the inverse Laplace of these three terms. L inverse of 1 by s, I would like to write directly. L inverse of 1 by s is 1. 2 by s cube, where 2 is constant, right? And think about 1 upon s cube. What is inverse Laplace of 1 upon s cube? Where n is 2. So t square by 2 factorial. Okay, now inverse Laplace of 1 upon s raised to 5. T raised to 4 by 4 factorial. And you can simplify further. 1 minus t square, okay, and plus t raised to 4 by 24. Okay, this is the final answer of this question. Question number 2. Now sometime you will be given questions like this: s plus 4 divided by s square plus 9. Okay, so how to solve, how to apply the formula of inverse Laplace? So first you can separate these two terms. L inverse of s by s square plus 9 plus here 4 L inverse of 1 by s square plus 9. Now think about this question. We have two different examples. This is the inverse Laplace transform. This is the Laplace transform of cos 3t. So you can say inverse Laplace of this function is cos 3t plus here 4 constant. Now inverse Laplace of 1 upon s square plus 9. So which formula is suitable? You can refer this formula. Formula number 3. 1 upon a square plus a square is equal to 1 upon a sine 80. But here a square is 9, so a is 3. So 1 by 3 sine 3t. Clear? Okay. Good. Now, next question. We will think about this question 2s minus 1 divided by s square minus 4. Same concept. First we will separate these two terms. L inverse 2s by s square minus 4 minus L inverse 1 by s square minus 4. Right. Now L inverse of 2s by s square minus 4, 2 constant, and Laplace inverse Laplace of remaining term is hyperbolic because in denominator it is s square minus 4. So cos h 2t minus here 1 by 2 sin h 2t. Okay. Now we will go for inverse first shifting theorem. We will apply inverse first shifting theorem. In which case we will apply? Equation is 1 by s plus 4 square plus 25. Okay. So how to solve this equation? So this is like a inverse Laplace transform of this question. So think about inverse first shifting theorem. What is first shifting theorem? So if you want to find out the Laplace of this question, e raised to minus 40 into sine 5t by 5. Okay. How to find out the Laplace of this question? Think about it. Right? So what you will do in order to solve the Laplace of this question first? 1 by 5 constant. So as per our first shifting theorem, first you need to think about the Laplace of sine 5t. So Laplace of sine 5t is 5 by s square plus 25, and then you will apply shifting s tends to s plus 4 because a is minus 4. S plus 4 square plus 25. So you will get this answer, right? So this is the reverse process. Here we want to find out the inverse Laplace of this. So obviously this will be the answer. But how to think about this question? So here s plus 4 is combined, right? So think about it, s plus 4. So consider for one moment, consider s plus 4 is s. So it will be 1 upon s square plus 25. Just we are considering s plus 4 is equal to s. And then imagine what is the inverse Laplace of this. 1 upon s square plus 25. So write down in one step. Inverse Laplace of 1 upon s square plus 25 is 1 by 5 sine 5t, right? And then here we have considered s plus 4 as s. So due to that we will apply shifting e raised to minus 40. So in one line you can write the answer. And L inverse of s minus 2 by s minus 2 square minus, let's take 9. Okay. So here same way, now consider s minus 2 as s and think about this question. So when you will take s minus 2 as a s, So this formula will become s by s square minus 9. Okay, so what is the inverse Laplace of s by s square minus 9? Minus is there, so it is hyperbolic function. Okay, so you can write cos h 3t, and for s minus 2 you can write e raised to 2t. Let's take one more example. L inverse s plus 1 divided by s minus 4 square plus 1. Okay, now you cannot replace s minus 4 by s, but in whole term we don't have s minus 4 everywhere. So first we have to convert s plus 1 in terms of s minus 4, then you can consider. So our first term will be s minus 4 square plus 1 s minus 4 plus 5. Okay, and then as per the previous question we will divide into two terms. L inverse s minus 4 divided by s minus 4 whole square plus 1, and second term 5 by s minus 4 whole square plus 1. Clear? Okay, so we have two terms, two examples. Think about it first. S minus 4 divided by s minus 4 square plus 1. So just replace s minus 4 by s. So it will become s by s square plus 1. What is the inverse Laplace of s by s square plus 1? You know very well. It is cos t only. Cos t. And shifting e raised to 4t. Now for this term, 5 constant, and think about 1 upon s square plus 1 first. It is sine t, and e raised to 4t. You can take e raised to 4t common, and remaining term cos t plus 5 sine t. Yeah. Now a little bit difficult question. In L inverse of s plus 1 by s square plus s plus 1, how to find out this term? So first we will think about the previous formula. What was the previous concept? Just we used to convert in this term, right? So in denominator we want this type of factor. So convert this denominator into our convenient term. So how to write down these two terms? S plus 1 by 2 whole square. Okay, and here put the rational number which is suitable as per this denominator, right? When you will solve this term, it is s square, middle term is s, done, s square s, and third term, constant term, is 1 by 4. But here we want 1, but 1 by 4 is there. So what we will add? So it will become 1, right? So 1 is there, and we have 1 by 4. So what value we will add? You can consider this way. Let's take alpha, right? So what is alpha? Alpha is 1 minus 1 by 4. It is 3 by 4. So here you can write, now it is balanced. You can say both are same. Now same we think about numerator portion. Here it is s plus 1 by 2. Same way we will try to convert s plus 1 in terms of s plus 1 by 2. So s plus 1 by 2 plus 1 by 2. Now you can separate s plus 1 by 2 divided by denominator part plus here 1 by 2 divided by s plus 1 by 2 square plus 3 by 4. Now as per the previous question, you can think about, just replace s plus 1 by 2 by s. Consider this way. So what is this formula? S upon s square plus 3 by 4. What is the inverse Laplace of s upon s square plus 3 by 4, where a square is 3 by 4? Okay, so s square plus a square. So cos s upon s square plus a square. So cos 80, but a is root 3 by 2t. Okay, because a square is 3 by 4, and shifting e raised to minus 1 by 2t. 1 by 2 constant. Here again, this is the formula of L inverse of 1 upon s square plus a square. So 1 by a, 1 by root 3 by 2 sine root 3 by 2t into e raised to minus 1 by 2t. Okay, now you can simplify. You can take e raised to minus 1 by 2t common, and remaining term cos root 3 by 2t. Here you can simplify this term, 1 by root 3 sine root 3 by 2t. Okay, this is the answer. Then, okay, now there are few advanced question about the inverse Laplace transform, and we will discuss in next session. We will use partial fraction to solve the inverse Laplace. Thank you.